So sixth I will write reactions with H2 means if these elements reacts with H2, then what will be the products reactions with H2. In short, we can say the hydrides of these elements. Very simple hydride. If I talk about the oxygen, if it reacts with a hydrogen, then it is going to give me a H2O. And this is very simplest compound we should know. We know, right? That it is a water. Based on this, the hydrides or the reactions with the hydrogen, the other compound is going to give this way oxygen, then sulfur. If it is a sulfur, then this is going to give me S H2S. Okay, then selenium will give me the compound. This tellurium will give me a compound this way, and the polonium is going to give me a compound. So H2S, okay, water everyone knows how it smells, how it tastes, but H2S gas, okay, if you get any time any chance, like in higher studies or yeah, here you also if you smell the H2S gas, okay, it is smelling like a rotten egg, okay, smell of this is very foul, okay, it is having a very foul smell, okay, with respect to the hydride. So these are the hydrides. First hydride or reaction with the H2 of the oxygen will give you H2, then sulfur, which it will give you a hydride. So these are the hydrides or um, the product when the elements of group 16, that is oxygen, sulfur, selenium, and polonium, are reacted with hydrogen. Now, what is the order of the acidic strength? What is the order? What is the order of acidic strength? Means which one will be a strong acid among these? If you compare the acidic strength, which one will be the good acid? Now, acidic strength will depend on how easily it can give its H plus. Now, here if you see the atomic radius increases down the group, means if I want to represent oxygen, this is the oxygen atom. Okay, I will just represent in this way. If this is the oxygen atom, and this will be a hydrogen, right? This will be a this sort of hydrogen will be there, or I'll draw a little bigger. Let's say this is oxygen. These will be the hydrogens, two hydrogens which will be connected to it, and you can see that the bond length will be from here to this, right? Then if I talk about the sulfur, as we go down the group, the size increases, isn't it? So as we go down the group, the size increases. Means here, let's say this is the size of the sulfur. Okay, this is the size of the sulfur, and this is the hydrogen is same, okay, hydrogen size is not going to change because okay, this is the atomic, this is the bond length, right? This is the bond length, the distance between the nuclei. So this is the compound I can represent H2S, this is H2O. Then third compound I can represent selenium like this, selenium H2, like still bigger size of the selenium atom. I should use these tools. Yeah, this is the selenium atom, and the oxygen which is connected to it, it will be of this sort, right? It is still smaller. Now the bond length, right? Now the bond length will be from here to here. Now it will be the these bond lengths will be maximum in the case of the polonium hydride. Here it will be the so till the tellurium, sorry, till the tellurium the bond length increases, means the strongest acid, the strongest compound, strongest hydride of this element, this is that is the tellurium, it can give its hydrogen very easily, means these bonds could be broken very easily. So bond length is more of the hydrogen and the metal, that is tellurium, and that's why the this is the strongest acid. Okay, so H plus could be given very easily. So the acidic strength, what I can say is that in general, acidic strength it increases down the group. Okay, maximum is for the tellurium. This is a radioactive element. So maximum is for the tellurium, the acidic strength. If you want to write the uh, increasing order of the acidic strength, then H2O will be the least, then H2S, then H2 selenium, and the maximum will be H2 tellurium. So this will be the order of the acidic strength. Next is reaction with O2. With oxygen. If the elements are reacting with the oxygen. So I will write the elements, and if they are reacting with a reacting with the O2, then I will write reaction with O2. Okay. That is oxygen, sulfur, selenium, tellurium, and the polonium. Let us understand what type of oxide it is going to form. See, oxygen re oxygen reacting with the oxygen has no meaning. Okay, I will not write anything over here. Sulfur, if it is sulfur is reacting with oxygen, then two compounds are possible. It is sulfur dioxide and the sulfur trioxide. Selenium will form only oxide of this type, selenium oxide, and tellurium will form a this. And since this is polonium is radioactive, it is not going to form any of the oxide. So these are the oxides which are being formed by sulfur, selenium, and the tellurium. Now here oxidation state, if it is a sulfur dioxide, sulfur dioxide is changing to, let's say, SO3 by further reaction with oxygen, then here the oxidation state of sulfur is +4 and here it is +6. Means sulfur is changing from the +4 to +6. Means here the reducing sulfur can also go in the oxidation state of -2. It can form the compounds where the oxidation state of sulfur could be -2. Means the oxidation state of the sulfur with respect to sulfur can vary from -2 to +6. But this reaction which I have shown, the conversion of the sulfur dioxide to the sulfur trioxide is more feasible. Okay, this is more feasible. Sulfur dioxide means changing from a +4 to the +6 means the oxidation of the sulfur dioxide. Here the oxidation of the sulfur is taking place. So this is oxidation means sulfur itself is getting oxidized. Since sulfur itself is getting oxidized, it can act as a good reducing agent. It can act as a good sulfur dioxide. SO2 can act as a good reducing agent because itself can go from +4 to the +6. So if we talk overall, then from top to bottom, oxidizing power increases. Okay, oxidizing power increases. So these are the things about the oxides of the group 16. That is oxygen, sulfur, selenium, and tellurium and polonium. Only sulfur, selenium, and tellurium are going to form a oxide. Others are not going to form the oxide.